So, next one called the Doctor. I'm Matt, and today I'll be going over some of the optimizations that you'll see coming to virtual data sets in the HDF5 2.0 release, coming hopefully later this month. So just an overview in case you're not familiar of what virtual data sets are. A virtual data set, as opposed to a regular data set, is kind of a collection of pointers to data which is stored in other source data sets. And those source data sets can even potentially be in other files. And there's a few different use cases for this. One is if you have some very large data sets that you want alternate views into, or to kind of pseudo copy without having to, actually duplicate the storage space and go through the potentially time-consuming operation of copying it. Virtual data sets are one way to achieve that. Or another use case, if you have many, many smaller data sets that you want to associate with a spatial region in one larger composite, virtual data sets are a way to achieve that and give, kind of one consistent shared handle into these many different regions that are represented as multiple small data sets, potentially different files. So one of the problems that arises with these is that when you have a lot of sources, in the range of thousands, tens of thousands, certain operations tend to slow down pretty dramatically due to the overhead incurred by just, in certain scenarios, having to iterate through all those sources to do certain operations. In dramatic cases, this can lead to certain reads and writes being, as much as 10 or 100 times slower than on regular data sets. And so we have a few different improvements, some of which are finished, some of which are in progress, aimed at mitigating this problem and closing that gap in operation time between virtual and regular data sets. So one of these is to delay the layout copy. Just as a quick overview, the layout of a data set, in this case, what's important is that the layout of a virtual data set describes all of its sources, where they are, their file name and dataset name, and essentially what the virtual data set needs to read from them at read or write time. The issue we notice here is that we typically copied the layout internally, not in a user visible way, at the time the dataset was opened immediately. But of course, when you have thousands upon thousands of mappings in that layout, this copy can be pretty time consuming. So the solution we found is that, because the user doesn't need that layout immediately, they won't need it until they read or write or a couple other operations. We can just delay that internally, check it with a flag, and then only copy it at the moment it's necessary, because it won't be modified due to how virtual data sets work internally. So just by delaying that copy, which doesn't really require much internal changing at all, we immediately saw around a 30% improvement in dataset open times, just by bypassing that costly copy. This didn't impact read writes themselves directly, but because the open is involved in that through line, this can be pretty impactful for certain workflows without a lot of reads per open. Our next improvement was to implement shared name strings. So I mentioned that the layout stores those source dataset names and source file names. And normally that's not really a big deal. File names aren't very large. But again, if you have thousands of them or tens of thousands, and especially if you're using procedurally generated file names, which you might be if you're, collecting data which has some spatial region associated with it and want to procedurally assemble that later, you could potentially have pretty long file names, to the point that doing that memory management overhead, that allocation, freeing, moving them around, storing that, could be very time consuming, not just in terms of operation speed, but also in terms of memory usage when the file's open, and even maybe in terms of file space. And so the solution here was to use pointers to previous source names whenever possible, instead of duplicating them. So now, at the time that the virtual data set is being assembled and the source entries are being added to it, we track which sources have already been seen. And so rather than duplicating the dataset name and the source file name, we simply use pointers to previous values. So if you have, 100 references to datasets in one file, now instead of allocating memory for each of those 100 separate instances of the same file name, it'll just be one instance, and then we'll have 99 pointers to it. As a consequence of this, because that ends up being stored in the file, This did come with an update to the file format, which is currently slated to be pushed as the file format 4.0. And the accompanying changes to the heat block for this are, I believe, at the moment, the only changes in 4.0. So the impact of this change was around 25% faster dataset close, but the main focus of this wasn't so much operation speed as it was the overhead memory and file space. So getting something which should hopefully get more at the kind of core problem with many mappings is a spatial search. So I mentioned that kind of perhaps the biggest portion of the slowdown with virtual data sets is having to iterate through all those thousands of different sources. And the reason this is time consuming is because, imagine you're doing a read of a virtual data set with 50,000 mappings, mappings, what they're called internally, 50,000 source data set regions that compose it. So it has all these pointers to 50,000 different source data sets. If you want to read from one region, we need to figure out which of those source data sets have their data within that region of the virtual data set, which means running 50,000 some intersection checks between your selection and the regions of each of those source data sets, which can pretty quickly become time consuming. And the solution we've gone with here is to use a spatial tree to kind of skip what I think of as the obviously empty overlaps. Over there on the right is a visualization of a spatial tree in 3 dimensions. The essential idea is sorting each of those hyperrectangles, those selections internally. And then if we know that we kind of divide the rectangles into, say, left and right, if we know that nothing on the left, none of the region on the left is selected, we don't need to individually check every single one of thousands of rectangles on the left side of the search space. We know that the bounding box containing it has no overlap, so nothing inside has an overlap, which allows us to, at each step, cut out, hopefully, a significant number of comparisons. In the kind of computer science notation, this takes the number of comparisons from O of n to O of log n. So, for, say, 100,000 data spaces, 100,000 data sets, this could take the number of checks from 100,000 down to around 16. Now, that's very much an ideal case, depending on the exact layout. If the tree isn't exactly balanced, it could be, people probably won't see improvements that substantial, but somewhere around that order of magnitude change in the number of checks is what's expected. Now, this is still a work in progress at the moment. In fact, as soon as we finish up here, I'll go back to working on this today. But the expected results of this are hopefully much lower overhead on read-write operations for virtual data sets with a lot of source data sets to, again, close that gap between the virtual data set and regular data sets. It might not be multiple orders of magnitude just because even if the number of comparisons changes, there's still going to be the time taken for sorting the data spaces, doing the internal operations of the tree. But ideally, the improvement here will be pretty drastic in terms of time. And so those are the optimizations that will be part of the 2.0 release for virtual data sets. Any questions or comments?
Yes, I have a question. On the first improvement, delay of copying, you said it's pushed to until read and write. Does it mean that now my read and write operation is 33% slower?
That would depend on what proportion of the read or write operation that the layout copy makes up. In principle, yes, we haven't deleted any work here in the read-write case. We haven't made it worse either because this operation had to be done at some point, but there were a lot of operations previously which did this work and had no need to do this work. So not every workflow is improved here, but there are a lot of operations on dataset which are now no longer doing unnecessary work.
I see. And another question, is it necessary to copy the whole structure instead of the parts of the structure that related to the to the data set in question?
Are you talking about At dataset open or even after it's all copied?
Dataset open, yes.
A dataset open immediately, I don't think any portion of the layout was necessary, which is why we were able to delay it. If you're talking about whether we could, maybe copy individual portions of the layout, I think maybe potentially that could work, but I'm not sure. I mean, the really costly thing was copying the information about the mappings, because that's what scales badly as you have, more complicated workflows. And I'm not sure if you can do better or if it'll be simple to do better than delaying the copy to read write.
I see. And two other questions. I simply don't remember if VDS works with a parallel library. I think it did work, right?
I don't recall off the top of my head.
Okay. And another is, does it work with the current swimmer and VFD swimmer?
That's another question that I'm not sure of at the moment. I have to check.
I believe for VFD swimmer, there was some workaround in user's guide, but I don't remember for the current swimmer. Okay, thank you, Matt.
Yeah, thanks for your questions, Elena.
Matt, I had a question. Is there any option of forcing a layout copy on open if at the user level, if the user decided for whatever reason that maybe he wanted to preload layouts?
Right now, there's no option for that. One thing I mentioned that it's delayed until read or write. That layout is something the user can actually access through a property list operation. They can request the layout, and that's another operation which will trigger the copy. So it is possible for the user to, in a slightly roundabout way, force the copy by accessing it, but it's not a toggle they can enable.
Okay, I see. Is there any, do you think it's just better from a design perspective to not expose that through the open call? Does it add perhaps a complication that no one would really use?
Like I mentioned, when I was answering one of Elena's questions, this is kind of, at least as far as I'm aware, a strict improvement in the sense that there are now operations which are no longer doing unnecessary work, and read and write workflows already had to do this. They're now just doing it at a separate time. So I'm not aware of any compelling reason to expose that behavior to a user-controlled option. For our trees, for the spatial search, it is planned to have an option at a property list level for whether or not it's used, because there could be scenarios where the overhead of creating and managing a tree could lead to slowdown. So in that case, that is planned.
Okay. All right. Thank you.
Thanks for the questions. All right. Anything else, anyone's? Any other comments or questions? All right. So we can wrap up.
Looks like nice improvements.
Thank you. All right. Well, thank you, Matt, so much for jumping in and presenting, and we'll see everyone back here next week for Alexander.
Yeah, thanks for coming, everyone.
Bye, everyone.